Welcome back to Clean Code and Programming Principles, the Ultimate Beginner's Guide. My name is Spiros, this is the Programming Duck channel, and in this video we're going to look at the principle of least knowledge. Before we start, why are we looking at this principle? And it's directly because of the requirements and the limitations that we looked at a few videos ago. So things like code changes should be easy, code shouldn't have hidden dependencies because you won't remember they're there and no one else will. And code should be independent and decoupled so that changes are easy, so that we can change code X without affecting code Y and Z, and so on, those chain reactions. And this principle is very important in preventing those things and in helping those things. So, what is knowledge in code? Basically, any time that some code uses some other code, it means that it knows about it. Okay, and if it knows about it, it means that it is a dependency. And what that means is that now you cannot change that dependency, because if you change how it works, then the thing that's using it is going to break, right? So if you have a function A that uses function B and everything works correctly, but then you change function B, how that works, you're going to break A. And the problem with this is that a ton of things may be using a particular dependency. So this is the thing we're talking about. You change function A, which is used by 10 other things, you break all of those 10 things, then you change those to accommodate and you break the other 10 things or that were using those that you just changed again. You get into that chain reaction and that's quite difficult to deal with. And finally, not only that, but you might not even realize or remember that these dependencies exist. So not only is it a lot of work for you to go and make those changes, but you also won't remember to make them. And of course, if you forget, then you'll break the code. So what do we need to do about this? Long story short, we need to manage the knowledge, which means the dependencies in code effectively and well. We need to set them up in a particular way so that we can make the changes without having all these issues. So when we change code, what kind of modifications can we make? And for the purpose of this principle, let's just say that there are three kinds of modifications you can make to code. And those are something which doesn't change the contract, which means the call signature and what that functionality actually does. Another kind of change you can make is you can change something that's private. And we'll get into each one of these in the following slides. And finally, you can make a change to something that's public, which means it can be used by basically anything in the code base. So let's get into these one by one. So the first kind of change and the safest change you can make is something that doesn't change the contract of a function or any functionality you have. So if you look at the code on this slide, for example, we have two functions that have the same call signature. They have the same name, they accept the same argument, and finally, they also do the exact same thing. So both of these functions are 100% equivalent. So if in your code base you change from the first version of this function to the second version, then nothing else could possibly be affected by this change, which means that your changes stop there. You don't have to make any other changes because you made this one. Nothing else will care about this change. So this is fine. This is the safest change you can make. Next, we have what if you change something private? And what something private in this case means is just something that's the majority of the code in the code base cannot use. So this might be because it's a private method in a class, so nothing else in the code base can reach in and use it. Or if you're using modules, then it's some functionality in your module that you don't export. So again, nothing else in the code base can take it and use it. It's private. So it can only ever be used by a very limited amount of code. So for example, here is some code. And in this case, we have a method called private calculation. Now, this is written in JavaScript, which doesn't actually have private methods. Right now, they are actually in development, but for all intents and purposes, pretend that this is a private method. So if you were using any other language that actually has private methods, or even if you were using JavaScript, in the future, in JavaScript, this will be a private method and pretend it is one now. So anyway, so private calculation is a private method. And as we can see here, it's only used by the getter for the area. It's not used anywhere else in the entire code base. So in the next version, we delete private calculation. So, deleting something means you change the contract of how it works, like it's deleted, right? Anything that uses this method will of course be affected. So we also go to get area and we modify it so that it now works, since we change the function that it was using. That's what we have to do. Every time we change the contract of something that is being used by something else, we have to go and fix it. Otherwise, we'll break the thing. So we modified get area, and now we're happy. Now everything's great. We finished our changes here. And the key part is, because this method, this private method that we deleted, was only used here, the changes we have to make are extremely small. So this is what we want. We want changes to be easy like this to make. We don't want to make a change and then we have to go change 30 other things. So something like this code is how we want to do the majority of the changes that we have to do. Okay, we want things private so that this is the result. We change 1 or 2 things or something. We don't change 10,000 things. And then next, you've got, what if you change something public? And the same exact pattern applies again. So anything you change the contract of, you have to go and then fix whatever was using it. Otherwise, you would break it. You have to accommodate whatever was using it with those changes. So if it's something that's public, it means it can be used by basically anything in the code base, which means that if you change something public, you're going to have a lot of work to do to fix the things that were using it. I hope that makes sense. So we don't want to be making these changes most of the time. Now, sometimes, unfortunately, we will need to make changes like this. This is just the nature of things. So we might have a class and we might need to change the public methods of that class or the interface. It's just how it is. It's nasty if we need to do that because it could result in those lots of changes, but sometimes it's just how it is. Okay, so what do we do? So the only thing we can really do is try to create sensible units that we probably won't need to change in the future. So the only way we do that is by applying separation of concerns effectively. So for example, if we have a class called circle that deals with circle mathematical things like getting the area, calculating the circumference or something, what are the chances that we're going to need to change a method in there? If we have a getter for the area, we're not going to need to change how that works. It would be ridiculous, right? Because what are we going to do? Change the area to get the circumference or something? It wouldn't make sense. So if we have a sensible unit, it's unlikely that we'll need to change it. And that's all we can do. We just have to try our best based on what our project is and applying the principle from the last video, separation of concerns. We just have to try our best to create those sensible units. So we do that. We have our public functionality. And then for everything else, we keep everything else that become private, because then that produces the effect we saw 2 slides ago, where if something is private and we need to change how it works, no problem. That's an easy change. And the final point about this is to remember to be pragmatic, which means remember to do what's best for your project and not go too crazy with these principles. So maybe you can imagine, but if your project is still in its starting stages, if it's still small, you may be creating abstractions for your code, units for your code, that you might need to change again in a few days. And if the project is small, that's fine, right? Because changes are easy when a project is small. And let's be honest, you don't know as much what kind of abstractions you're going to need than you do after you spent a few months on the project. Requirements are more stable, more solid, no pun intended, and things like that. So, that's okay. That's an understandable place to be in. But there needs to be a balance. You don't want to go to the place where you don't apply this principle at all. You're like, I don't care what I do, and I don't care if everything's public or private. You don't want to completely ignore the principle, but at the same time, you don't want to spend too long over-engineering everything. Don't spend weeks thinking about, is this a good unit? Maybe I should. What if this happens? What if that happens? No, just do the unit, refactor later if needed. You know what I mean? Be pragmatic, use your professional judgment. And finally, this principle is the foundation of quite a few principles, and it all originates from minimizing the knowledge that code has of other code. So for example, we have the law of Demeter. That's another principle. And I won't go into too many details of what these do. You're free to look at them on your own if you'd like. They should make sense now, I think, now that you understand the core concept. But the law of Demeter basically attempts to minimize the knowledge that code has of other code inside function calls. So when some code uses an object, it shouldn't reach into the object to get another object and then do operations on that. That's too much knowledge spanning from here is your function, here is this object, your function knows about this object, and oh, guess what? Your function also knows about this object. So now this is brittle. If this thing changes, it breaks two things. That's the thing we're trying to avoid. Another application is using immutability. So immutability is good. We went over it a little bit in the KISS principle, but it's good because it keeps code simple. And more importantly, you don't need to remember, you don't need to have the knowledge of what's going to change, what's going to be affected if I change this variable, or what is this variable now, or what could have affected this variable. I hope this makes sense. This is all a knowledge thing, which you can completely avoid caring about if you use immutability. Another application is minimizing side effects and function purity. But if you apply the principle of least knowledge, then this naturally arises, right? Because a function is impure if it does things which are outside of its local scope. If you modify this thing that's used there, and again, this is a knowledge thing. If you do that, what's going to break? What's going to be affected? What else could modify this thing? You just want to completely eradicate that. You don't want to worry about that knowledge. So whenever possible, try to have pure functions that don't access anything outside of their local scope and that don't modify anything outside of their local scope. And then you avoid this entire range of problems for free. There are many more applications of these principles, but a lot of them are more combinations of all the foundational principles in this series rather than just the principle of least knowledge. Anyway, so that's all for this video. I hope it was useful to you and I hope it makes sense. And in the next video, we're going to look at the next principle, which is about abstraction and don't repeat yourself. If you like this video, then please click the like button and subscribe if you would like to be notified when the next videos in this series come up or other videos like this. It really helps the channel when you do that. And finally, if you have any comments or even counter arguments to this video, then please leave a comment below. All right, thanks very much and see you in the next one.